Hello students. So in the last 3-4 classes we have covered all the, you can say, the basic fundamentals of kinematics of circular motion. Okay, and I had asked you that I am going to take a long video lecture on the what, on the practice session, okay, on the application of these concepts that we have learned in these previous classes. Okay, so guys, today we are going to see a lot of problems, and we are going to make concrete our concepts that we have learned in these last few chapters, last few lectures. Okay, so let me start with the word, guys, with a very basic question. Okay, with a very basic question that I'm having. That question is from HCV only. So these questions that I'm going to take, guys, the upcoming 3-4 questions are from HCV, from the objective objective questions that is given in the objective 1 and objective 2. Okay, so guys, the question number 1 that is given in the book is so let me write down the question, guys. So it says like this, guys: when a particle 1 minute, guys. Okay, when a particle moves in a circle with a uniform speed, with a uniform speed form speed, then guys, they are asking that these are the options that it is given, and it is a single correct question. The first option is its velocity and acceleration are both constant. Okay, its velocity is constant, but acceleration changes. Third is, guys, its velocity is constant, its acceleration is constant, but velocity changes. And the last one, guys, its velocity and acceleration its velocity and acceleration both changes. So guys, I'm giving you a 30-second. You can pause, you can think about it, and you can take your answer. Okay, so now guys, let me discuss this very simple problem, but it's very what, a conceptual problem that is given in the objective one. Okay, this is the question number 1 only from HCB. Okay, so guys, if you see here, the answer would be what? The answer would be this. Okay, the answer would be what, guys? That is, its velocity and acceleration both is going to what? Change. Why, guys? If you see, we know that if a particle is moving on a circle with a uniform speed, of course its magnitude of velocity is not going to change, but its direction is going to change. So velocity is going to change, that's for sure. Okay, but guys, if you see, the acceleration that it is going to have is only the centripetal acceleration, because there is no tangential acceleration, because speed is not changing. But the centripetal acceleration is also, guys, what? It is acting towards the center right now in this direction, and then, guys, what? It is in horizontal direction, now it is what, guys? In vertical direction, now it is again in horizontal direction, and then again, guys, what? In the vertical direction. Yes, of course it is acting towards the center, but guys, the direction of the vector in the space is what? Continuously changing. Okay, so we will say, guys, that what? Acceleration is also what, guys? Continuously changing in the space or plane, whatever you want to say. So we can say, guys, that here velocity and acceleration both are changing. Okay, so the correct option in this case is what, guys? D. Okay, now let me take one more similar simple problem from HCV. Okay, and uh, later guys, after 2 3 problems of these questions that I want to take, after that I'll take some good numerical problems, easy problems only. Okay, so this lecture we are going to take only easy problems. Okay, the next lecture again I am going to take some practice, okay, if needed, and there we will take some difficult problems. Okay, so let me guys write down the question number 2. So question number 2 says like this guys, okay, that an object an object follows a curved path. The following quantities may remain constant during the motion. So guys, here they are saying that it is a of course objective 2 guys, so there are multiple options could be correct guys. So the options that they have given is speed, then B is velocity, and the C is acceleration, and the D is magnitude of acceleration. So that it is very like simply associated with the first problem. So guys, here if you see, if I take the uniform circular motion, the particle is moving on a what guys? Particle is moving on a circle. Okay, particle is moving on a circle. So guys, here if you see, if it is moving on a curved path, direction has to change guys. Direction must change. There is no other option if it is moving on a curved path. So guys, velocity couldn't be the constant thing. Okay, velocity could not be the constant thing. So guys, this is not possible at all. Okay, this is not possible at all. But guys, yes, speed could be constant, because if you see that direction is changing in the case of uniform circular motion, but speed could be what guys? Constant. So guys, this is one of the correct answer that we can have. Okay, now coming to the acceleration guys. So we know that guys, acceleration is a what? Vector quantity only. So guys, here if you see, in the case of uniform circular motion, we know that the direction is what guys? Keep changing, but the centripetal acceleration right now will be what guys? Omega square r, or r omega square will be guys what? Same. So magnitude wise it is constant, but guys, direction wise it is what? Keep changing. Okay, direction wise what? Keep changing if you take about uniform circular motion. So in that case guys, we can say that 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 acceleration as a whole means direction plus magnitude could not be what guys? Constant in that case. So that is not also possible. Okay, so guys, only magnitude of acceleration, yes, it is possible that it could be constant. So guys, this is what? Correct. So guys, what we can say, A and D are the right options that we can have. Okay, I hope this is also guys settled. Okay, this problem is also settled. Now one very good problem guys is there again, that is question number 3 from objective 2. So let me write down that problem also guys, let me write down that problem also. Question number 3, question number 3. So guys, here it says like this way, that the position vector the position vector of of a particle in a circular motion about the about the origin sweeps out equal area equal area in equal time. Its velocity its velocity sorry, its option A is velocity remains constant. B. Speed remains constant. Acceleration remains constant. And D. Tangential acceleration remains constant. So guys, you can pause the video and you can try this problem by yourself, and then we can discuss this problem. Okay, so try this problem guys, and then we will discuss this. Okay, so here guys, if you see, the question is what? It's very simple question. Again, if you see guys, you are covering equal area in equal times. It means what guys? It means that you are covering equal angle in equal time. I hope you're getting my point. Then only guys what you can have this thing. So if you see guys, this is, if this is theta, this will be also what? Theta. If this will be also what guys? Theta. This will be also what guys? Theta. If this is delta t, this is also delta t, this is also delta t, this is also delta t. So guys, it means we can say that it could be done, as per the given options. It can be done with the given option guys. What? Velocity remains constant, that is not possible at all. Okay, that is not possible if it is moving on a circle. So guys, that we have to eliminate directly. Okay, we don't need to think about it. Okay, but guys, speed remain constant. Yes, if speed is guys what? Constant. Yes, we can achieve guys what? Equal distances in equal amount of time. Okay, and if equal distances we will cover guys, of course we will cover what? Equal angles also. Okay, so guys, we can say yes, if speed remains constant, we can achieve the required what condition that is given in the question. Okay, so we can say guys, yes, this is possible. Okay, this is what? Possible. Okay, now guys, coming to the acceleration remains constant. So guys, acceleration, how it could be constant guys? You know that if it is moving on a circle, guys, we know that it is always going to have at least some centripetal acceleration towards the center. And if it is having some centripetal acceleration towards the center, the acceleration is going to change its direction. So guys, it is not possible that it could have what guys? It could have a same acceleration throughout the motion. That is not possible guys. What about the tangential acceleration? So guys, here if you see, if speed remain constant, we can say in that case guys, what will happen? The at, one minute guys, at will be what? 0. Here guys, at will be what? 0. At will be what? 0. So guys, tangential acceleration is what? Magnitude wise what? 0. And direction guys of tangential acceleration we can't define, because it is a null vector. So any direction we can take. Okay, so we can directly say that tangential acceleration remains what? Constant. Okay, tangential acceleration remains constant because its value is what? 0. It is a null vector. Okay, so guys, we can say yes, it is a constant thing. Okay, so guys, this is also what? Correct. Okay, so the correct answer should be what guys? Here B and D. The correct answer should be what guys? B and D. So guys, these are some simple problems that I wanted to take. I have taken. Now we'll go with what guys? Little bit what? The numerical based problem. Okay, these are some bit of, you can say, the theoretical problem that I wanted to take. I have taken. Now guys, we are going to see some problems which are what? Which are fundamentally related to what? You can say on the numericals. Okay, on the numericals. Okay, so guys, let me put a question in front of you. So question number 4 guys, question number 4. Okay, so it's a very easy question guys, that there is a particle. Okay, there is a particle whose initial velocity v is what guys? 0, and and it has it has tangential acceleration, 2 meter per second square, Radius is what guys? 10 meter. Okay. Tangential acceleration is guys what? 2 meter per second square. Question is, question number 1 guys, find the velocity of the particle, angular velocity, and and acceleration of the particle at t equal to 2 seconds. Okay, so this is the problem guys, a very simple problem I have put it in front of you. That guys what, a particle which is started moving guys what, on a circular path, and and it is having guys what, it is having the initial velocity what guys, 0, and it is going to move here, it is going to move here guys with the constant tangential acceleration, that is what guys, 2 meter per second square. The question is what guys, find the velocity of the particle, angular velocity of the particle, and acceleration of the particle at t equal to what, 2 seconds. Okay guys, so let me solve this problem. If you want to solve, if you want to try guys, you can try, you can pause the video and you can try, otherwise let me solve this. Okay, so guys see, it's a very easy problem. So the first problem guys, the first part of the problem, that is guys, v is equal to what, u plus at. We can apply, we know that if the particle is moving on the circular path, even then guys also, if this a is what, a tangential that we have to take, we can apply this formula, v is equal to u plus at. So guys simply use this formula. So v is equal to what, 0 plus at is what guys, 2, and time is guys how much, 2. So v will be how much guys, 4 meter per second at the t equal to 2 second. Okay, that is the first question guys. Second is what, the omega guys, we have to find out. So omega, how do we get guys, we know that v is equal to what, r omega. So from this relation guys, we can directly find omega value. The omega value will be what guys, that will be v by r, and v is how much guys, that is 4, and r is how much guys, 10. So this will be what guys, 0.4 radian per second. Okay, 0.4 radian per second, that would be what guys, your omega. Okay, that would be what guys, your omega. Now coming to what guys, coming to the third question, that is acceleration guys. So acceleration, we know that acceleration is guys always your a tangential plus a centripetal. So guys we know that on a circular path guys, a tangential and a centripetal, 1 minute guys, a centripetal, they both will be what guys, always perpendicular to each other. So we can say guys that a net will be what guys, under root of at square plus ac square. Okay, at square plus ac square. So guys from here we can say that a will be how much, under root of at we know guys already, that is given how much, 2. So that is what guys, 4. How do we get guys ac? So ac is very simple, that is what guys, r omega square. So r is how much guys, 10, and omega just we have calculated, that is what, 0.4. So 0.4 into 0.4, 0.4 into 0.4 guys, and that is what, that is 1.6 meter per second square guys, that is your AC. So guys you can put here this as a 1.6 into what, square. So guys it will become what, it will become 2.56 plus 4, that is what, 6.56. Okay, so guys this is what a net that you will be having in meter per second square. Okay, that will be what guys, your the acceleration, the net acceleration that you will be having. And in this net acceleration guys, a centimeter is how much guys, 1.6 meter per second square. So this kind of a problem also guys you might see in front of you. Okay, so this is also a very simple problem that I have taken. Okay, now guys let me take one more problem like this way. Question number 5. Okay, question number 5 guys, these are pretty much easy problems guys, but they are going to give you a certain level of what, confidence, in terms of what, in terms of the understanding the that how you have to approach these problems. Okay, Now let me take one more easy problems guys. Okay, so suppose guys it is given a particle start moving on a circular path with initial angular velocity omega naught and had and have angular acceleration alpha, which is equal to k into root theta. Okay, k into root theta, where where k is constant and theta is the angular position angular position of the particle. Okay, now guys they are asking find find the find the angular velocity of particle at any any position or angular position. Okay, at any position or any angular position guys. Okay, so guys let's see this problem. Okay, let's see this problem guys. And given initial angular position of the particle is 0. Okay, initial angular position of the particle is guys what? 0. It means that let's say it means guys what? It means that let's say this is your circle. So guys this is your reference line. So right now particle is here guys. Okay, right now particle is here, and from here guys it is going to move. Okay, so now you have to uh, tell the position of the particle. Sorry, you have to tell the guys what? You have to tell the 1 minute guys. I think God. Yes. So now you have to tell the guys what? Omega at any general theta. Okay, omega at any general theta when the particle would be at general angular position theta. Okay, so guys this is the question. It's a very simple question. Similar questions are pretty much given in the aerodovs also. Okay, so if you want to try, you can go on the part one of the like the kinematics part of the aerodove. You can see these kind of problems there, and you can attempt those problems also. Okay, so guys let me solve this problem. If you want to try, you can pause and you can solve this problem. Otherwise let me solve this guys. Okay, so if you see here guys, this problem is very easy. Okay, just we have to use what? The differential equation of what? The kinematics guys. So here if you see, the alpha is given how much? K under root theta guys. So guys always remember, whenever alpha is given in terms of theta or omega, always remember guys, then always use alpha is equal to what? Omega into d omega by d theta. Okay, this you have to use as we have done it in a kinematics. Okay, similarly guys here also in the circular motion kinematics we have to use the same funda. Okay, so guys this is the thing that we are going to use here. Okay, so what we can do here, alpha we can replace with this general differential equation, omega into what? D omega by d theta is equal to what guys? K root theta. Okay, so guys what we can write? Omega d omega is equal to K root theta d theta, and guys now integrate the both the sides with the appropriate limits guys. So when theta was 0 guys, your initial velocity was what, omega naught, and let's say guys when your angular position is what, theta, at this point guys your angular velocity is what, omega. So guys if we integrate this, we can say that it will be what guys, omega square by 2, limit is what guys, limit is omega and omega naught, and guys here k root theta integration will be what guys, root theta integration will be, if you see, so it will be theta power 3 by 2 divided by 3 by 2, so it will become what guys, 2 by 3 theta 3 by 2 power 3 by 2 limit 0 to theta guys. Okay, so if we solve this, what we will get guys, omega square minus omega naught square 2k into 2 by 3 theta की power 3 by 2 minus 0, so that we can leave guys directly, so we can say omega square is equal to omega naught square plus 4k by 3 theta power 3 by 2, so guys omega is nothing but what, under root of omega naught square plus 4k by 3 theta 3 by 2 radian per second, whatever the unit is given guys, you can use that. Okay, so guys that would be the answer of this problem. Okay, that would be the answer of what guys, this problem. You can see this, and it is very much easy problem guys. There is nothing like some rocket science is there. You just use the basic fundamental kinematics equation, you can solve this problem. Okay, you can solve this problem. So guys this is question number I think 5 we have taken. Let me take few more questions guys, okay, so that uh, you get more clarity about these kind of problems. The next lecture that I will take guys, that will be more focused on what, some very good problems I'll take from SS Kroto and Erudov, and even from some other good books also. Okay, I'll pick those problems, and then we will see those problems also. But today we are just focusing on what, the very simple problems which are what based on the kinematics of circular motion. Okay, based on guys what, the kinematics of what, circular motion. So let me take few more problems. Okay, give me a second guys. Okay, so here only I will write question number 6. Okay, question number 6. So let's see guys some more problem. Okay, okay. Mm, this is the question. Okay, simple question only. What it is saying, it is saying like this: a wheel of a wheel of 1 minute guys, of diameter, of diameter 1 meter. Okay, if it takes, if it takes 30 revolutions, revolutions per second. Okay, 30 revolutions per second, the linear speed, the linear speed of a point, of a point on its circumference, on its circumference, on its circumference will be equal to, will be equal to n pi meter per second. Find the value of n, find the value of n. Okay, find the value of n guys. So let me solve this problem. Okay, let me solve this problem for you guys. So solution. Okay, solution. So easy problem guys. Okay, if you want to try, you can try. Okay, now let me solve this problem. So guys here if you see the 1 minute, the particle which is moving here guys, okay, its angular velocity about this is given. Okay, and that is what, diameter is what guys, 1 meter. So we can say, let me make it enlarge, okay, a little bit, because this will be what, this will be 0.5, okay, this will be what, 0.5, and sorry, 1 meter only, yes, yes, 1 meter. So guys, this will be what, 0.5. And now guys, if you see, yes, uh, omega is given how much guys, omega is given that it is doing 30 rpm, sorry, 30 revolutions, 30 revolutions per second guys, okay. So guys, here you have to see some basics, okay. The basics is what guys, see, one revolution, one revolution, how much angle you cover guys, 2 pi, okay. So guys, it means in 30 revolutions, in 30 revolutions, how much you will cover guys, you will cover 60 pi. So 60 pi radian guys, that is the angle that you have covered in 1 second, okay. So guys, what will be your omega in radian per second will be how much guys, that will be 60 pi radian per second. That would be what guys, your omega in radian, not in the revolution, okay. So guys, we have converted from one unit to another unit the omega value, okay. We have converted our one unit, the omega, from one unit to another unit, and guys, omega we got 6 pi radian per second, okay. Now guys, it's very easy. So they are asking that velocity of any the linear speed of a point on its circumference will be equal to. So guys, if you see, this is the particle, this is the particle guys, which is what, which is moving on this, and they are asking that what is the velocity of these particles guys. So if you see guys, all the particles are moving with the what, omega only. They, all the particles are guys what, moving with the omega. So we can say guys, in this case, the particle which is what guys, lying on the circumference, its velocity will be what, v is equal to r omega. Velocity will be what guys, v is equal to r omega. So v, we can find out guys, r is how much, 0.5 into omega is what guys, 60 pi radian per second. So guys, if we multiply this, it will become automatically what, in meter per second, and that will be how much, that will be 30 pi meter per second. So guys, we can say that in this case, n will be how much, 30. That would be your answer, okay. That would be what guys, your answer. So I hope guys, this is also settled for you, that how do we get guys what, this value, okay. Okay guys, now let me take one more problem for you, okay. One more problem guys, let me take for you, a little bit easier only, I am taking right now, okay. Later we will take a bit difficult in the next class, okay. So question number 7, okay, question number 7 guys, okay. So the question number 7 says like this guys, that a particle, a particle moves on a circular path, on a circular path with a constant, with a, sorry, not constant guys, with a angular deceleration, angular deceleration, with the angular deceleration beta, that is directly proportional to what guys, omega, which is directly proportional to what guys, omega. So this is your angular deceleration, where omega is the angular velocity, omega is the what guys, angular velocity. So guys, this is given. If its initial uh, if its initial angular velocity angular velocity is omega naught, is omega naught, then the mean angular velocity, it is I think from Erodo only, okay, and mean angular velocity of the body of the body over the whole time of rotation till it comes to rest, till it comes to rest is, okay, we can leave guys, okay, come to rest, okay. So this is the question guys that they had asked, okay. So it's a good problem, yes, of course, not like very difficult, but it is a moderate good problem that we can say, okay. So let me take this problem, I'll solve this, and then today we'll wind up the session for today. In the next class I am going to take some very good, you can say conceptual problems, okay. So these examples that I have taken or that I am going to take is going to just give you a glimpse of what that how do we have to approach the problems, okay. But in the next class or in the next lecture you will see some very good application of what the fundamentals concepts that we have learned in the previous lectures, okay. So let me solve this problem guys. If you want, if you want to try, you can try, okay. uh, Let me solve this, okay. So guys, if you see solution, so guys, if you see your alpha, here they have given beta, I'm just taking alpha guys. Alpha is given minus k root omega, okay. Where guys k I have put it from my side only because it is a, uh, if you want to remove the proportionality constant guys, you can put a constant here, and minus sign because guys it is a deceleration. So guys, that's why I have put it a minus sign, because the it is going to reduce the velocity, okay guys. So of course it is a deceleration, its direction and the omega direction will be what, opposite to each other. So from my side only guys I have put it this, well, sign minus, okay. Now guys, let me solve this problem. So guys, if you see, because here omega is there, so what I have told you guys, if you see this kind of a thing, omega or theta, you have to use which formula? Omega into d omega by d theta is equal to alpha, okay. So that only I'm going to use here. So guys, if you see, omega d omega by d theta is equal to what, minus k root omega. So guys, if you see here, what we can do, we can directly write that here there is root omega will get cancelled guys, and here the in the left side we will have what, root omega left. So guys, root omega d omega is equal to what, minus k d theta, okay. So we have to integrate this. First let's integrate and calculate how much theta you are going to have, okay. So guys, if you see, initial angular velocity is how much, omega naught, when theta is what, 0 you can say, okay. And later when you have covered theta angle, your velocity becomes what, 0. So guys, if we do this, so what we will get, what we will get, so we will get guys what, that is uh 2 by 3 omega ki power 3 by 2 guys, and limit is what, 0 to omega naught, and that is equal to what guys, minus k theta, okay. So guys, here if you put the limits, what you will get, you will get 0 minus omega naught power 3 by 2 is equal to minus k theta. So guys, theta how much we will get, theta will be, guys what, 2 by 3 omega naught 3 by 2 k will come in the denominator guys. You can check, okay, you can check this thing, you can pause, and I think you can see that this would be the theta guys, okay. This will be what guys, theta. Now guys, what we want, this is your displacement guys that we got, okay. So from 0 to theta, this is the thing. So displacement is what guys, this much, okay. So we can say delta theta or angular displacement is what guys, 2 by 3k omega naught power 3 by 2. Now guys, if anyhow I can get delta t, then I can find out what, omega average. I hope you're getting my point, okay. So guys, to get the omega average, I need delta t. Okay, I need delta t. So how do we get, guys, delta t? So guys, if you see the alpha was given how much, guys? Alpha was given, 1 minute guys. Alpha was given, let me change the color. You can see this part also. Alpha is given what, guys? Minus k root omega. So guys, because I want to find out the time in this case, so I can change this alpha. I can replace this alpha with what, guys? We can replace with d omega by dt, because I am looking for what, guys? Time right now. Okay, so I can use this k root omega. So guys, from here, d omega by root omega is equal to what? Minus k dt. Integrate this again, guys. So at t equal to 0, guys, your velocity was what? Omega naught. And at t, guys, your velocity becomes what? 0. So root omega, guys, 1 by root omega integration is what, guys? 2 root omega. You should, you can solve this. Okay. I generally remember this 1 by root omega or 1 by root x integration is what? 2 root x. Okay. You can do that, guys. Okay. So this is what? 2 root omega. It saves a lot of time. Okay, so guys, this is 0 and this is omega naught, and this is what? Minus kt. So guys, if we solve this, what we will get? We will get minus 2 omega naught is equal to minus kt. So minus minus, guys, cancel. So t, we got how much, guys? 2 root omega naught by k. Okay, so guys, the delta t is how much? 2 root omega naught divided by k. Okay guys, so this is the value. So guys, now finding the omega average is very easy. That is what, guys? Delta theta divided by delta t. So guys, delta theta is how much? We have calculated 2 by 3k, 2 by 3k into omega naught power 3 by 2 divided by 2 by k root omega naught. Okay, so guys, if we solve these both, what we will get? K cancel, 2 cancel, guys. What we will have in the numerator? 1 by 3 omega naught power 3 by 2, and divide by, in the denominator, guys, we will have what? Root omega naught. Okay, root omega naught. So guys, if we solve this, what we will get? If you see, it is what? It is omega naught by 3. If you see, guys, 3 by 2, yes, omega naught by 3, guys, that would be the answer. Okay, so we can say, guys, the average angular velocity in this case will be what, guys? Omega naught by 3. So I hope, guys, I have taken some 7 8 problems, and these 7 problems that I have taken, I think it have given you some sort of what? A brief idea that how do we approach the problems in the kinematics of what? Circular motion.